Hi, I'm Matt Ingenthron, a Senior Director in Engineering here at Couchbase, and today I'm going to talk with you about Couchbase as a cloud-native database. So let's get started. Today we'll talk a little bit about how we define cloud-native, then we'll talk about the code and infrastructure behind what a cloud-native application is. I'll show a little bit of a demo of a cloud-native deployment, and then we'll talk about some of the differentiation and conclusion. So first, let's define this term cloud native. You might have heard it before. Maybe you even have a definition. Let's see if yours and mine match. So just to check first, what I did is I went to Google and I typed in the search phrase, define cloud native. And sure enough, what came back was a screen full of advertisements. So everyone from VMware to D2IQ to Amazon to Red Hat are willing to spend money to tell me about how cloud native is defined. So that's one way you could look at it. Cloud native is very cool among all the companies, and we all want to be part of it. Of course, I'm joking a little bit, but if you look over there on the right-hand side, there's this section about an organization called CNCF. So the Cloud Native Compute Foundation does publish what they call the Cloud Native landscape. And this is a taxonomy that defines all of the things that you need to be cloud native, everything from app definition and deployment to orchestration and management to different runtimes. And so if you look, it's actually a really comprehensive list. So this tells us that probably everybody wants to be cloud native. And as a matter of fact, if you were to try to scroll around this page, you'll see that it doesn't even fit, even with these small icons, doesn't even fit in a single browser window. There are so many different pieces. And in fact, even if you look over on the right-hand side, you have things like serverless and monitoring and observability, and even things like the platform that I would consider very key to a cloud native deployment. So obviously, cloud native is pretty big. There's a lot to it. Now, you may have noticed in that upper left-hand corner that there is a little logo, and that little logo is, of course, the Couchbase logo. Couchbase is a member of the Cloud Native Compute Foundation. We have been for several years. So that means that by virtue of our joining the Cloud Native Compute Foundation, we are cloud native, right? We've successfully achieved cloud nativeness. Well, maybe not so much. I know I'm joking around a little bit, but let's check Wikipedia. That was one of the other links over there on the right-hand side on that first page. So Wikipedia talks about cloud native as being an approach to software development, something that uses cloud computing to build scalable applications in dynamic environments like public, private, and hybrid clouds, and in particular, having immutable infrastructure via declarative code. And it talks about it as an architectural style or paradigm. So that's a pretty good definition. That gives us a sense of maybe how cloud native might be a little different. Cloud native apps need to be resilient, manageable, and observable, and they allow high impact changes frequently with not too much work or what's called toil. So thing is though, actually, if you look at that page, it's even edited pretty frequently. So even Wikipedia doesn't necessarily agree on what cloud native is. But all joking aside, let's talk a little bit about code and infrastructure. So we're going to build up a cloud native deployment on top of Couchbase. One of those words earlier was declarative infrastructure. So what do I declare in order to have a Couchbase cloud native infrastructure? It might be worthwhile for a moment to think about the word declarative versus imperative and how you would go about that. So imperatively, what you might do, especially historically, what you might do is go to your issue tracker, make a request among your IT organization to get some systems, then maybe file another issue asking the ops people to set up the app servers, go ask the build team to deploy the app and configure it. Now there's this problem where you have to get somebody who has sufficient privileges over the database to be able to give the app access to the database because we want separation of concerns in certain environments. And then after I get to that point, I still have to go get the network team to set up a load balancer for the service. And so that would be imperatively how I would go about that. I'm describing what are the steps involved in getting something deployed. Now, there is another approach, right? I can just declaratively say there's a cluster. There are buckets in this cluster. there are users identified by credentials, and those users have a particular access control. And then there's an app that exists defined by a container, and that app should have access to that infrastructure. So those are the two different sort of approaches. So when we're talking about declaratively, how do we go about this? Let's build up a stack. So at the base level, Kubernetes itself has a number of core objects. So from an external view, from a user perspective, you have things like services or microservices. These are things that are accessed by web applications or by browsers or by mobile apps. And those use different kinds of network access, which are then built on deployments. And deployments are sets of pods. And pods are really just groupings of containers, a fairly simple definition. Now, we also need some state for the applications. So Couchbase as kind of an application within the Kubernetes infrastructure, we need a way to describe that state. So within Kubernetes, the way you do that is you create what's called a custom resource definition. And Couchbase has one. So we have a couple of cluster resource definitions. This really just tells us what the attributes are of a cluster or a bucket within a Kubernetes cluster. As we're building up that stack, the next level is really kind of the process that runs it all, the operator. And this is the Couchbase autonomous operator. Really all it does is listens in a loop and reacts to changes of other resources within the system. Simon Murray has a deep dive session talking about how the operator does what it does. But we also have something called an admission controller, and the admission controller validates correctness and can even augment a deployment or a resource that you submit with defaults that you left unspecified. So over here on the left-hand side, you see a truncated version of what that deployment looks like, right? So we tell Kubernetes, we have a deployment, and that deployment consists of this thing called the Couchbase operator, which is an image that we publish online, and it has a name, and then that runs. There's some more details, but that's an easy way to think about it. Then you also have a set of principles, right? And this is not misspelled. This is principles with an A. In security terms, we're referring to users or people. So in the case of Kubernetes, Kubernetes has this object called a secret, and a secret can contain things like usernames and passwords or client certificates. We also have to have a set of Couchbase users, right? And that's really kind of an application context of credentials to access the database. So so for that, we just use these two different YAML files you see here below, the secret and the Couchbase user as one of the custom resources that we define for deployment. So after that, you need to have a sense of what resources is that application going to need. So at this stage, we haven't even really deployed a cluster, but we're going to. So I need to deploy a cluster, and a cluster needs to have a couple of attributes like, what are the number of nodes? Which version do I want to run? And that's actually kind of an interesting question, because what happens if you want to edit that later and upgrade, as an example? But also things like, what buckets do I have? So in Couchbase, a bucket is sort of analogous to a database. It's a place for your data to be stored and then to be able to be accessed by other deployments within that Kubernetes cluster. You also need to think a lot about security. In the case of cloud, everyone's always thinking about security, particularly because there are public clouds or hybrid clouds. And Couchbase is very strong on security. So we have an idea of a resource as a Couchbase group. That's really just a definition of roles within a cluster. And then we have a role binding that binds users to groups through labels. And here below, you actually see the totality of a group and a role binding for the application that I'm running here locally. So that gives you a sense of what are the resources I need to define to be able to declaratively. So I've now declaratively built this stack from the Kubernetes base objects all the way up through groups and role bindings so that I can have users access buckets. Sounds pretty simple, right? Obviously, the other thing I'm probably going to need is a service, an application. So this is a very minimal service. In this case, it's a quick Java application that I and my colleague Graham had written just to demonstrate transactions, which appears in another session here at Couchbase Connect. So this is a really simple version. Like before, it has an image and it has a few other things that are defined here. In particular, one I'll call your attention to is the config map. In the config map, you see there's this section that talks about volume mounts and volumes. That's really what that's doing is it's taking the credentials that I've put into a secret and then it's mounting those into the pod at runtime. And that way the application, when it was written, doesn't even need to know what the username and password are. And it can even respond to changes if they change over the course of time. So we do that through a deployment. And we also have a configuration map that can pull in some additional information. Finally, to describe that to the outside world, that's where you would use the idea of what's a service to Kubernetes. So a service is something that's actually providing services to maybe another application in a microservices case or to an end user. Maybe it's a web front end. So finally, we just have to tie that all together with the service. This particular service is defining a couple of different ports. One is really the HTTP front end. The other is really a place to get metrics. And I'll talk a little bit more about that in a bit. So at this stage, you're probably saying, wait a minute, I was promised simplicity, right? This is supposed to be simple. You've just walked me through something like 7 different pages worth of YAML files that describe what's happening with a given deployment. And it is true that this is a paradigm shift. You are really going from an environment where you might have historically had to work across different teams and have different projects, and now you can actually approach your infrastructure with code and declaratively. So just going back to that definition earlier, it's an approach in software development that uses cloud computing to give you immutable infrastructure and declarative code for a given application deployment. So it really is a change in your approach, but I promise you there's actually some good stuff about it. So I won't make you sit through the creation of an entire deployment of this application. So what I did is I grabbed a quick screenshot. And you'll see I started at 1:34 p.m. And I went to GKE, but it could have been EKS or AKS. Any of the public clouds, could even be a system locally. And there I created a cluster. And I shrunk it down a little bit, but you see how quickly I was able to create the cluster. And then in a declarative way, I just did a kubectl apply -k that uses a so-called configuration that starts with a K. And it just applies all of the configuration I have from this GitHub repository I have that defines the application. So it deploys all of the CRDs, the service accounts, and everything necessary to get that app deployed. And the whole thing is done in a little over 5 minutes time. Technically, it's not done because the pods are still starting up, but that gives you a sense of what you can do if you refactor the way that you work with infrastructure and treat infrastructure as code. So with that, I want to get into a little bit of a demonstration. So here's the scenario for the demo. I have a working cluster, and it's for a game. It's for a social game. And we're about ready to launch a new version of the game. And we have a lot of new marketing to go with it. So it's kind of impossible to capacity plan. We never know when we might have a celebrity tweet that might make this app go crazy. In case you think that's a funny scenario, it has happened to Couchbase before. Ask me about it if you're interested, and I'll tell you the story. But the idea here is that we are not going to be able to know exactly. It's not like you're a company-facing enterprise app where you know exactly how many users you're going to have. So you need to slightly over provision and then monitor to figure out what to do as the application, as the workload is figured out. Okay, so let's have a look at the demo. What I have here is a Couchbase cluster. It's running in a public cloud. And I have a particular bucket, GameSim, that has a workload running against it. It is a transaction simulator that I'm using in another demonstration here at Couchbase Connect. So what you're seeing in it is a reasonable number of operations per second going on. And if I were to have a look over in Grafana, as in just for an example, I might be able to see just kind of an overview of what's happening inside the cluster. Where is the pod workload going? So as you can see, I have a few different cluster nodes that are running here. Let me refresh this because I think it might actually render a little differently in a moment. So I have a few cluster nodes associated with that deployment. Yeah, sure enough. Okay, so I have a few different cluster nodes that are associated with that deployment. Some of those are in the past, and some of them are my current nodes, my CB example 0, 1, and 2. Those are current nodes associated with that deployment. So if I were to just have a quick look over here, if I were to kubectl get Couchbase clusters, oops, I left out the S, but it works the same way. You see that I have, in fact, one cluster size 3 that's running. That's from the deployment I did earlier via customize. And if I do a kubectl get Couchbase buckets, you'll see that I do, in fact, have one bucket. GameSim has 100 megabyte. And it's up and running. So I want to add some capacity. That's what we said earlier to the existing running cluster. So for that, I'm going to pull out my editor of choice. And I have a YAML file that actually has multiple documents in it. The 3 dashes there separate different YAML documents. So what I want to do in this case is I'm going to turn this from 100 megabyte to 200 megabyte. And then I'm going to find the size in here, and it's currently a 3-node cluster, and I'm going to turn it into a 4-node cluster. So if I do those two things, and then kubectl apply -f and cb cluster, what I should see is, sure enough, it said you've modified this document about GameSim that is now configured. You've modified this document about the cluster that is also configured. And if we were to go back and just kind of look at the current status, we have our deployment, our Couchbase cluster resource now has 4 nodes. And our Couchbase bucket resource should now have 200 megabyte, and that's on a per node basis, just like Couchbase normally works. And so if I do a kubectl get pods, what I would expect to see is, sure enough, I had 0, 1, and 2 as previously, and I can probably even see this over in Grafana at this stage, 0, 1, and 2 previously, and I should start to see the 3rd node come online. As a matter of fact, if I were to pop over here, yep, sure enough, I've got a rebalance going on. So I have 3 different nodes in the cluster. If I look at the servers, I should in fact see 0, 1, 2, and 3. A couple other things worth noting. Note that the if I hover over here, you see that the host name is actually a host name assigned based on the cluster name within Kubernetes. So the operator will automatically set that up per the deployment. And actually, I'm using a DNS SRV record internally to get the application to connect directly to that particular cluster. So if I were to just kind of come back over here, notice that CB example 003, when it refreshed, when Grafana refreshed, it gave me that view. If I were to have a narrower look at what's going on, I should see, I'm not sure why I don't see CB example 003. Oh, there it is. It's this little red line in here. So it's not taking workload yet, but as it comes online, it should start taking transactions workload just like 000 does 1 and 2. So that's a quick example of how approaching this from a declarative perspective, I'm able to manage Couchbase as a cloud native database. So I'm declaratively telling Couchbase via specific resources what I want it to do. And then the operator picks that up. The Couchbase autonomous operator picks that up and makes my will become reality out there. So I've now been able to provision, as mentioned, some additional capacity for my new launch. Now, I've talked a lot about Kubernetes, and that ends up being one of the most popular ways to kind of go about moving to cloud native, but that's not really the only way. In fact, I just sort of touched on another part of it. One thing that I'm very passionate about, those who know me, is I'm very passionate about observability. And people will talk about observability as having three legs to it. That's monitoring, logging, and tracing. So in the case of observability, really what we're investing in is monitoring with Prometheus via an exporter. So with the most recent version of the Couchbase operator software deployment, we have something called an exporter. And that's something that will export statistics from Couchbase in Prometheus format. So Prometheus can pick up those statistics, and then you can use them in any other system like Grafana to visualize what's actually happening inside the system or set up alerts associated with it. There's also FluentD. FluentD is one of those other tiles in that Cloud Native Compute Foundation landscape. FluentD is for log aggregation and log analysis. Although technically it doesn't do the log analysis portion, but it does help with log filtering. And so we're looking at some really interesting things that we might be able to do to combine and analyze the logs coming out of the different services inside Couchbase. There's also tracing, and we've long been involved in the open tracing project and have been shipping support for that for a couple of years with the SDKs. Now we're moving a little further down the path as open tracing and the open census project have merged into open telemetry, and we want to add additional capabilities to be able to get statistics or traces out of other components inside Couchbase to be able to understand where the time is going. Sometimes I like to say to the team, just imagine in the future, are things going to be more distributed or less distributed? And if your answer is more distributed, then we need to be building these kinds of tools to be able to make sense of the environment as it gets deployed. But it doesn't stop there. A couple of other things that we're working on are an open service broker. So there is a specification called the Open Service Broker API. And in Kubernetes, there's something called the service catalog. And what this really allows people to do is in a deployment, they can templatize and roll out a version of a service for, say, a development team to use internally. So that's in some ways even simpler than what I've been talking about. Rather than having a set of YAML that a development team necessarily needs to be aware of, development team can have an ability to just request that from a service catalog that's running inside Kubernetes and have a service provision for them that then they can grab all the secrets and other details associated with to attach. So if you imagine an environment where it's a template, kind of t-shirt size templating that I want to get a development cluster out of an existing Kubernetes deployment, then it becomes very easy to do. And that's what we're doing with the Open Service Broker. There's a Couchbase implementation of a service broker available right now in open source, and that's something that we're looking at doing some more with in the not too distant future. Finally, there's the pod autoscaler, the Kubernetes pod autoscaler. So this is really auto scaling in response to workloads. Over the last couple of releases of Kubernetes, the pod autoscaler has gotten a lot more capable, has a number of features that start to make it kind of appropriate for that situation like Couchbase, where we're running a stateful workload versus a stateless workload. Scaling up stateless workloads is usually fairly easy because you don't have to move a lot of data around, but scaling up a stateful workload is a lot more complicated because you don't want the scaling effect to actually have an impact on the overall work that's happening inside that stateful system. In other words, when I add a node to Couchbase and I rebalance, that may actually mean that I'm putting more workload on the system at a point in time when it is possibly under some pressure. So there's a lot more work to go there, but the team's been working hard on that, and we've got some really neat things that we're going to be talking about shortly. So the message I kind of want to leave you with here is Cloud Native is not just about Kubernetes, although that ends up being one of the more popular ways to kind of go about it, but also things like OpenTelemetry and FluentD and Prometheus that can exist outside the context of Kubernetes directly. A couple of differentiators and a conclusion for you. So Have I made the case that Couchbase is cloud native? I would argue that I have. Couchbase is a cloud native database in that we can work directly from declarative infrastructure, where you're sort of doing GitOps style declaring of the kinds of things that you need for deployment. It's very robust and automated. You don't need to take downtime for even things like application upgrades. Didn't demonstrate that here. I should say database upgrades. I didn't demonstrate that here, but as an example, if I were to go from Couchbase Server 651 to 660, that's really just a matter of editing my Couchbase cluster deployment and kubectl applying it, and then the operator will take care of it from there and handle all of that work. If a node fails in the middle of the night, especially on a public cloud, but even in your own private cloud infrastructure on something like OpenShift, you can imagine that provisioning that container or that pod back to another piece of hardware can entirely be done overnight. So Couchbase has always had auto failover. This goes a step beyond auto failover. Failure occurs. Couchbase can get you back to that declarative configuration by simply scheduling that pod and its associated persistent volume claim on another node within that cluster. It also supports this kind of modern CI/CD approach so that development teams can test and develop in a cloud native way. Everything I did in this particular demonstration, which I can share with you, is done that way. So everything from the container that runs the app to the database to all of the resources to bind it together, we're all done cloud development from the beginning to the end. It also supports an SRE-like approach, meaning that development and operations can plan and collaborate. So you can, for example, have your monitoring and management integrated in your production environment, maybe even use a limited subset of that in your development or test environment, and it's all part of that same infrastructure. So Couchbase is really at this level of being a cloud native database, and we did that building on top of the existing cluster manager. Couchbase has always had this ability since day one to be able to move resources around within a cluster and within kind of an internal microservices architecture. And so we've now just connected that up to a lot of the tech that's appeared in the last decade or so. A couple of resources for you really briefly. If you're interested more on the operator in particular, just hit couchbase.com/product/cloud/Kubernetes. And then the transactions demo is at the GitHub link specified here. I will also drop those into the chat associated with this video, but they're here for future posterity. I'd love to take any questions, and thank you very much for your time and attention. Hope it's been worthwhile for you to kind of understand what we mean when we say cloud native and how Couchbase achieves it. With that, thank you very much.